Alright, you are welcome back. Now let's start by loading the truss. Now we are in load and definition. Then I can go to load cases details and then I can add. The first one I will call it self weight. Then I will pick this to be dead load and then I will click on add. Also the second one, that will be dead load, that is other dead load aside the self weight, that should also be dead load. I will click on add. We also have another one, that is the imposed load, which is live load. I will call that live load. Then I'll pick live, then you click on add. Then we have the fourth one, which is wind load. I will call that wind load, then I'll pick wind here. Alright, then click on add, then I can close that. The next thing to do, let me click on load cases detail and click on add. Now I'm going to create a combination. Let's define a combination. In the question, we have about 3 combinations that is supposed to be considered. Let's see the question. The question says we should consider 1.35 of dead load and 1.5 of live load. Alright, so let's go back to Staad Pro. That means I will have to consider this because this is dead load, this is also dead load, and this is live load. This I will not pick it. Let me call it combination. Let me just give it a number like this, combination 1. Alright, then the factor for this one should be 1.35. also for this one 1.35, and then for this that should be 1.5, and then click on add. Then I'm going to have another combination. I'll call it combination 2. That says I should use 1.35 of dead load, 1.5 for live load, and 0.9 for wind load. Since that is the case, then I'm going to select all of this 1 to 4, that is, then I will take it over here. Then this one, that is a dead load, I will factor that with 1.35. also this 1.35. the third one is a live load, that should be 1.5, and this is a wind load, that should be 0.9. Alright, so combination 2 is the name. We click on add. Then we have the third load combination, 1.0 of dead load, 1.5 of wind load. Then I will create the third one. I will call it load combination 3. Alright, then I'll pick the dead load. Also this is a dead load, then just this as a wind load. Then this should be 1, this should be 1, and then this should be 1.5. Alright, perfect. Then click on add, then I can close. So now I have the load, I have the load combination. The next thing to do is to define the load, and afterward we can assign the load. Let's go to self weight and then click on add. I will just click the self weight. I don't need to factor this anymore. I have done every combination that needs to be done. Just click on add, then close. Let me assign it immediately. Click on self weight and then assign that to view, since everything we have self weight, and then click on assign. Automatically it will assign the self weight based on the section we picked. And then the next one, that should be the dead load. Click on add. The dead load is calculated to be 2.67 kilonewton. So I will go to nodal load, and then in the Y I will pick that to be minus 2.67. okay, then I will click on add, and then I can close. This node, you pick this node, this node, this, and then this. Then you can click on assign to selected nodes, and yes, then we have this node. The next one will be the live load. Click on add, and then you can go to nodal load. Now let me go pick the value. The value for the live load, that is 5.95 kilonewton. 5.95. so this should be minus 5.95. then click on add, then we can close. Now let's assign immediately. click on the nodes that should be assigned to. Then you can click on assign to selected node, then click on add. Then you can see it has been added. You can scale down the arrow if you wish, but I prefer not to scale it down for now to save time. Then the wind load, let me click on add, and then nodal load, the fy, let me pick the value. What's the value for the wind load? Obviously you can see the wind load is the highest, it has the highest magnitude, so that should tell you that a roof is more susceptible to wind load. So that is 9.38. then this should be minus 9.38. then you can add that as well, close. Then let's assign it immediately. Pick the nodes, this, and then this. Then I can assign to selected nodes. Then I have that as well. So let's first of all analyze using the combination 1. Alright, you can see this is combination 1. You can as well click on the drop down and pick the combination you want to use to analyze. So I'll be using first combination. Then I'll go to analysis and print, and then just click on add. Then you can close. Then you can now go to analyze, click on run analysis, then we can save. Okay, so we are done analyzing, and then you can go to post processing, click on done, and then I will take everything back. The only thing I will take is my combination 1, then click on OK, and then let's see the results. Automatically when you get here, the first thing that will get selected is the deflection. Okay, so let's see the deflection diagram. You can hold your control and then you try to zoom in like this. Okay, so I'm just trying to have a better diagram. Then you can now go to results, and then you click on view value, go to beam results, and then let's see the maximum displacement. Click on annotate, and then let's close that. Now if we zoom in, we have 1, you can see here we have 0.865 millimeter, and then which is the maximum here. I think this is the maximum. We have one here, 6.789. The maximum is 6.789 mm. Now we need to confirm if this truss passes the deflection check. We can go back to the material. What has been provided for us is that we should use a maximum allowable deflection of what? L over 240. So let's see which one is greater. Let me pick my truss, and then I can use the calculator. The maximum length is about 2.015, but let me just say 2000, and then divided by 240, that will give me 8.33, and from here the maximum is 6.798. Okay, so it means that the maximum allowable is greater than what we have, which is the actual deflection. Hence it passes the deflection check. Alright, hence it passes the deflection check. Then I can close that. That is one good result. Now we are done with the analysis. The next thing will be to go to the design. We can go back to model. You understand that you go to design, then on still design you pick a particular one, BS5400. Then you can select the parameter, and then the only thing I will take back, let me take this back. Which other one? Let me take this back. I can also take this back, SGR. I think that should be enough. Then you can click on OK. Then you can go to define parameters. The stiffness, this particular section I've explained it based on the clause in the first video on steel frame. Alright, so I'll pick this first one, click on add. KY, I'll pick the default, which is 1. KZ, I also pick the default, which is 1. LY, default is the beam length, so automatically it will fix that. I'll click on add. LZ, I'll pick on add. NSF, the same thing. PY, let me use 500,000. that is the grade of the steel. Click on add, then ratio, click on add, SBLT, road section. It can be built up section. Since it is angle bar, let me use built up section. Then click on add. Obviously you should know that built up section cannot be used for any kind of section. For example, if you are using universal beam, which is I section, it will be very difficult for you to have a built up section. It has to be all road. Okay, but when you have channel, you have angle bar, and then you have like Z section, all those can be built up. It can be code formed. And then track, let me print all critical, and then UNL, let me just add that. Okay, and then go to command. Let me just check the code. I click on add, then I can close that. Now let me start assigning them. This first one assign to view, this next one assign to view, this assign to view, this also assign to view. Just assign everything to view. Then the next one assign to view. The next one you can assign to view, also assign to view. The grade of the steel, the same thing. The ratio, do that, and then SPLT, same thing. Tracking, same thing. UNL, the same thing. And then check code, assign to view. Under the command, let me track. Actually, I can take the member takeoff. Then let me just add that and then close. Then let me do a member takeoff and then assign to view. Now we can analyze. Go to analyze, then you can run the analysis. Okay, so the steel design check has been done. You can go to view output file, then you can click on done, and then go to results, then click on steel design. Alright, then you can check your results. The first one we have here, you can see this one particular one is a top cut. You can see the dimension, that is 150 by 150 by 15. Okay, and you can see that it passes. Okay, you can also check the buckling stress. Alright, and then the compression capacity, also the tension capacity. You can do the same thing for all. This particular one too, it is passing, and then everything is passing, I believe. Okay, so this is how you can design it. You can check your member takeoff. So after the design and you are done checking the results, you might as well check one other thing, and that is the utilization ratio. Let me put this in combination 1, and then you can go to post processing. Alright, then under the results you can click utilization ratio. You can see it here, utilization ratio. Then when you click on utilization ratio, let me maximize this. You are going to see the utilization ratio for every element. The utilization ratio will give you an insight of the relationship between the section and the load carrying capacity. For a proper and accurate design, you cannot have an utilization ratio greater than 100%, and that is 1 unit. So if you look at all the members we have here, look at this. This is not even up to 0.1. This is 0.0758. Also, this not up to 0.1. Almost everything here is not up to 0.1. Okay, we just have few that are up to 0.1. This is a very good result. Alright, so you can do all this while you are designing. So this is how we load a roof truss, this is how we analyze it, and this is how we design it. I believe this video is useful to you. If it is useful to you, you can give the video a like, and if you have any question, you can put it in the comment section. I will definitely reply to it as soon as possible. And if you haven't subscribed, kindly subscribe to my YouTube channel, and thanks for watching.